Hi everyone, am I audible?
Yeah, yes, sir, audible.
Sir.
All right,
Yes,
thank
audible.
you. Thanks everyone for joining this meeting. Okay, so let's just start without any further delay. Because we just have the 1 hour time, so I just want to start on very time, so everyone is going to be understand each and every concept right way. All right, so today I'm going to discuss more about that the basic concept, like we discussed about that yesterday in class, how this SDN is going to be beneficial for you, right? Now we have to understand some prerequisite, like we have to understand the control plane definitions, we have to understand about the data plane definitions, we have to understand about the management plane definitions. Also, we have to understand what is the RIB, what is the FIB, what is the CEF, and how we can build the underlay connectivity and how we can build the overlay connectivity, and what does mean the underlay versus overlay. So we'll try to explore. These are the very basic foundation before you go and start learning about SD-WAN. It's very important for everyone. So I will try to cover these all things, and we'll try to understand in deeper side how the existing scenario router was basically utilizing these all things. Okay, so let's just start. Yeah. Anyone in the class who don't know Hindi, English, any language issues? Let me know, guys, if anyone have any challenges. So I will try to cover those as well. Okay, so very first thing, whenever going to be you start learning about SD-WAN, you must know about their controller behavior. Means if I'm going to use the SD-WAN, they have the different controllers, right? And these controller are basically known as the you have the vManage, vAnalytics, vBond, vSmart. That was the old name, and there's a new name is the vManager, analytics, right? Validator controllers, and also we have the vanish devices, which is going to be your actual end router that is going to be connected on the branch locations. So these are the old name and new name. But before I can do the deep discussion about the old name and new name, we have to understand the basic definitions. Let's suppose you have to forward any packet. Let me use my whiteboard. Let's suppose you have to forward any packet from the any source or any destination. Then how the behavior is going to happen? So this is the one router. Okay. Let me use different color. This is the one router. This router want to talk to another router. This is the R1. This is the R2. And below that router might be we have the switch, and below the switch we have the client connected here. Okay, this is my switch 2, this is my switch 1, right? And this is my client A, and this is my client B. So let's make the connectivity. Might be these two are going to connected in this way. I can use the ISP between them, any ISP, and then this is going to be this is going to be this, and this PC is connection here. So normal WAN. So this is your wide network. WAN connectivity. It's pretty simple, right? You guys are able to understand. Now this PC have the IP address 10.10.10/24. He want to talk to, let's suppose, 192.168.10.10 network. So how the routing decision is going to happen? In this scenario, how the routing decision is going to happen? So definitely, whenever you're going to be talk to one device to another devices, there are some kind of the communication need to be established. From the PC point of view, you must have to configure the gateway. So gateway might be your router interface. This is going to be 10.10.10.1. This PC point of view, the gateway is going to be 192.168.10.10.1. So your packet is going to be pumped on this particular interface as a gateway. And then after, this router is going to check the routing, because you are in the one network. This is the network B, this is network A. So if you want to go from one network to another network, you cannot talk directly. You require the layer 3 device. Layer 3 device can be your router, can be your switch, can be your firewall. These all are the network devices. Means who support the layer 3 switches also, L3 switch also going to be support the networking routing protocol. So you have to do routing, and based on that routing, your packet is going to be moved to the R1, and that it is going to further back to the your destination host. And when it is going to reply again, it go to the R1 and it's going to the R2 via the ISP, and it's back to the this B device. This is how the communication is going to be happen in the any kind of scenario of doing the communication in the WAN infrastructure. It's a pretty small topology, but it's very meaningful to understand the key concept. Now, if I talk about router, this router, this router have their own control plane. This router, they have their own data plane. And if I go for the R2 as well, this router also have their own control plane, and this also have their own data plane. So anyone know what is difference between the data plane and control plane? Anyone willing to define what is the control plane and what is the data plane? Any idea, guys? No?
Control plane is going to carry our policy routing information uh, throughout the network, and
Okay.
data plane is our user traffic that is being
Okay.
transmitted from one point to another point.
Right, Altaf. So guys, everyone, like we have to understand. So control plane is the just your nervous system. It's the brain. Just think about you are here, right? Let's suppose I have very bad drawing, right? Mr. XYZ here. He feeling thirsty. Means इनको प्यास लगी है. ठीक है? Who is going to give the like idea you are feeling thirsty? मतलब आपको प्यास लगी है. कौन सा आपका जो body part है is going to give the instruction. You feeling thirsty.
It's a brain.
It's a brain. ठीक है? Brain ने बताया you are feeling thirsty and you need to take a water. But can brain bring the water? No. So brain giving the instruction, then you use your hand, who's just going to carry your glass or water bottle, and you're just going to drink on that. That is going to be whole process. So brain giving the instructions, hey, you're feeling thirsty, and then after you taking the water by hand. So brain is the basically nervous system who just maintaining your all health status or your need, and based on that you have the different muscles, different body part who's going to perform different actions. So similarly, the control plane is the brain of your networking, brain of your wide network and networking, whatever you want to say that you can just talk about. This brain is going to give an instructions how you should react if anyone want to talk from one subnet to another subnet. And then your data plane is actual plane who is going to use and forward the traffic. Means actual packet is going to forward by your data plane. So let's suppose this PC want to talk this PC. First, it will reach to the gateway and it will concern to the brain. Hey brain, I want to talk. Brain is going to give instruction, yes. You can forward traffic via this interface. Then your actual data plane is going to be carry your traffic. So what are the brain in the control plane in the my legacy WAN? That brain is nothing. It's your routing protocol. Okay. So the routing protocol is going to act as a brain. What is the routing protocol? That is going to be RIP, OSPF, it's a BGP, it's a EIGRP, right? You're going to use the static routing or might be the ISIS. These all are going to be your intelligence engine where they're going to run the different routing protocol, and they're going to build a routing table, and based on that they going to be tell how you can just follow the traffic. And then your data plane nothing actual physical interfaces, actual your interfaces like gigabit ethernet, 10 gigabit ethernet, fast ethernet, right? Serial interfaces, those interfaces are going to be used to just forward the traffic. Make sense? So these routers are always going to use the control plane and data plane, and based on that you are going to be process the traffic. Now in brain, if I talk about, we have one of the brain engine that is known as a CPU, means the main component of the brain, main processor, like any devices, like you have a computer, your computer have the processor, motherboard, you have the laptop, the same motherboard and processor. If a mobile phone, that also have the processor, GPU, CPU, you can just check it. So CPU is going to be central processing unit, that is known as the main processor, who be going to process everything, means anything coming from the nervous system, brain, then it is going to be processed that packet via the actual data plane, and this is how your actual packet is going to be processed from one source to another destinations. This is how your control plane and data plane is going to work. Data plane is also known as, control plane is known as like central processing unit. They use the leveraging the protocol, routing protocol, different. But data plane is known as the actual forwarding plane. Sometime you can going to be asked, what is a forwarding plane? So forwarding plane is nothing, it's a data plane that helps to look up the destination IP address. It is going to check your rib and fib table. Generally it's a fib, not rib. Now we have to understand what is a rib table, what is a fib table. It's also going to apply the ACLs if needed. It's going to apply the NAT, and it is going to be make sure packet is going to be forwarded correct interface by leveraging the control information, that is a routing table. So this is what is the role of my forwarding plane. Means this is going to make sure whatever the traffic is coming from my routing table, means the direction is coming from routing table, that is going to be basically maintained while doing the forwarding. And if you talk about the key component, of this forwarding table, so forwarding table that is known as data plane. This having a multiple key component. That's first one is going to be they use the ASICs. ASIC is basically hardware forwarding chip. It's like every electrical devices or IT devices, they use the ASIC chips. Without ASIC chips, you cannot make the circuits. So they use the ASIC chip. They use the uh, like CAM engine, right? TCAM engine. If you're coming from the switching background, you know that they use the fast switching engine. So they're different component, but these are how they're going to process the actual data. Means when they're going to forward data, they use the ASICs, TCAM. If there are the switches, they use the fast switching also, MAC table also to just forward the packet. Means any PCs want to talk to another PC, they first go and check that all routing table. They just get that information how to forward the packet, and based on that, they are going to run that all process. Now, if I just compare, if I just try to compare, let's suppose here I have the control plane. Here I have a data plane. Just summarize. So what is the control plane? Make the routing decisions to make the routing decisions. That is a role of the control plane. Second, the processor CPU is going to be part of the key component, right? That is going to use the control plane. Third one, they use the routing protocol, BGP, OSPF, like that, right? And if I talk about data plane, that's actually going to forward the traffic. The role of the forward the traffic. This is the role of the data plane. Second, this is going to use the your switching concept like ASICs and all to just forward the packet. Hardware based like processing is going to happen, not CPU based. They're going to process the packet based on the hardware or ASICs, right? They not process the routing protocol. They process the actual data packets via the interface. So this is how the difference is going to be happen. And every router you're going to find the same, even not router, you are going to use the switches, also the same behavior is going to happen. Clear? Now, we have to understand whenever going to build a control plane, there is two table is going to be used, especially for the control plane. One is going to be your fib table and one is going to be your rib table. This fib is known as the forwarding information base, and this is known as the routing information base. Anyone, any idea what is the fib and what is the rib and what is different between rib and fib? Any idea, guys? Anyone want to say something? Except Altaf, he contributed a lot of. Come on, guys, थोड़ा ट्राई तो करो, हिंदी में बोलो, कोई दिक्कत नहीं. No idea? No one have any idea? Rib and fib? Okay, so let me explain. No problem. Rib is basically your routing information base. That's the actual collection of the all possible route. Means whatever the possible route you have, that is going to be under the routing information base, rib table. Means all possible route. Everything is going to under the rib table. But if you want to do the forwarding, like let's suppose you want to talk to one PC to another PC, so they actually leverage the forwarding table, means fib table, to just make the routing decisions. So let's suppose, take an example, this one router R1 connected with a R2 and this connected with the R3. Here I am running the OSPF. Here I am running the EIGRP. I'm learning the 10.10.10.10, sorry, 0/24 subnet from EIGRP. And this also sending the same subnet, this R1. So now R1 have two route, 10.10.10.0/24 from EIGRP. And the one route is going to be 10.10.0/24 from OSPF. Which one is going to install in the routing table? Anyone know? EIGRP or OSPF? Which one is going to be routing table? Come on, guys. Why you guys are so silent? Yes, Altaf.
EIGRP.
Yes, I understand. बाकी लोग को क्या हो गया? नहीं समझ में आ रहा है बिल्कुल किसी को भी? विवेक, विनोद, right? Gaurav, Ajay, Amit, Iswar. What happened, guys? So basically, we have to select the EIGRP because EIGRP have the lower AD value 90. This one having the AD value 1110. So actually, in case of the routing table, routing is going to be always built from the fib table. Actually, fib is equal to your routing table. Fib is equal to your actual routing table. Means whatever the routing you have. So all best route is going to be in routing table. Means fib table. Best route always going to be a fib table. But these both route is going to be your rib table. Rib is basically routing information base. Means all possible route. All possible route are going in the my rib table, but best route is only going in the fib table. Clear? So this is how rib and fib is going to come in a picture. I hope it is clear to everyone. If any doubt, please let me know. Now we have to understand the one more concept before I jump to the my SD-WAN concept. If you are going to the normal routing, you are going to discuss about very important.
I have one doubt. This
Yes.
rib and fib table is L3 tables, or it is
Yeah, purely is routing, so
L2 one?
definitely L3. It's complete
Okay.
L3. We are talking about routing. Okay.
Okay.
Now we have the two more protocol. One is known as the routing protocol. Second one is known as the routed protocol. Anyone know difference between the routing protocol versus routed protocol?
Routing protocol is
Yeah,
control
routing.
protocol, and routed which is used to carry the traffic like IP, IPv6, MPLS.
IP, very good. IPv6 means actual traffic. You talk about that is routed protocol, right? Okay, good. Vivek, you want to say something? We know the Vivek. I think one people speak.
Sir, same which they said that routing process is a best part selection in the routing protocol and routed in the IPv4 it select the forward. जो
That's
पैकेट
correct.
वो फॉरवर्ड करता है कौन से
हाँ,
IPv4 में उस फॉर्मेट में वो उसको बोलते हैं राउटर टू.
बिल्कुल बिल्कुल सही. देखो होता क्या है, बिल्कुल सही. थैंक्स विवेक एंड विनोद. So देखो होता क्या, routing protocol is actually going to give the actual interface, basically how you can reach from one destination to another. जैसे आप इससे समझ सकते हो, देखो अब ये गूगल मैप खोल रहा हूँ, तो आप लोगों को एक चीज़ समझाता हूँ। होल्ड ऑन। तो मैं यहाँ गूगल मैप पे गया, यहाँ से मैं सर्च किया एयरपोर्ट, ठीक है, डायरेक्शंस, देखो। सो ये जो पाथ दिखाने का काम हुआ ना, देयर इज मल्टीपल पाथ। यहाँ से आपको यहाँ जाना है, ठीक है ना, सपोज नहीं सॉरी, यहाँ से आपको यहाँ जाना है। सो यू हैव दिस पाथ, यू हैव दिस पाथ, यू हैव दिस पाथ, बट मल्टीपल पाथ आपके पास है। दिस इज गोइंग टू टोल्ड बाई योर राउटिंग प्रोटोकॉल। ये सिर्फ रास्ता बताते हैं, एक तरह से आपका मेंटर होते हैं, बट काम तो आप ही को करना है ना। जैसे जीपीएस ने क्या किया, जीपीएस ने आपको रास्ता बताया कि हाउ यू कैन रीच फ्रॉम दिस लोकेशन टू दिस लोकेशन, व्हाट ऑल पॉसिबल पाथ अवेलेबल, कौन कौन से पाथ में जाओगे तो ज़्यादा ट्रैफिक मिलेगा, कौन में जाओगे तो कम ट्रैफिक मिलेगा, एंड हाउ यू कैन रीच दैट। बट इफ आई वांट टू गो, तो क्या मुझे इसको देख के पहुंच जाऊंगा? नहीं, देख के नहीं पहुंचा, मुझे कार लेनी पड़ेगी, या मुझे वॉक करना पड़ेगा, मुझे मेट्रो लेनी पड़ेगी, मुझे बस लेनी पड़ेगी। देन आई नीड टू ट्रेवल फ्रॉम दिस लोकेशन टू दिस लोकेशन। सपोज करो बाइक से गया, बाइक पे बैठा, और बाइक यहाँ से मैंने स्टार्ट किया और बाइक से इस रूट को पकड़ा और मैं यहाँ पहुंचा। दैट इज योर राउटेड प्रोटोकॉल। राउटिंग प्रोटोकॉल, ये जो मैप बन के दिया ना, ये राउटिंग प्रोटोकॉल काम होता है। राउटेड प्रोटोकॉल, जो बाइक पे बैठा मैं, जो कैब किया, जो मैंने जिसके अंदर मैं बैठा, जो मुझे कैरी करके ले जा रहा है, मीन्स व्हाट इज द गोइंग टू कैरी मी फ्रॉम वन लोकेशन टू अनदर लोकेशन, दैट इज माई routed protocols. So similar way, in my previous example, if I talk about routing protocol is like your different protocols. Hold on, guys. Like we have the OSPF, we have the BGP, we have the EIGRP. These are the routing protocol. It's going to tell me the best possible path, right? Best possible path, how I can reach from one source to another destinations. But to go from one source to another destination, I need the routed protocol. And these routed protocol can be your IPv4, IPv6, IPX, Apple Talk. These are the different protocol, etc. They're going to use to carry my actual traffic from one location to another locations. So this is the difference between the routing protocol versus routed protocol. Clear? Any doubt here? Anyone have? Please let me know. Give me thumbs up if everyone is agree with me. Every concept is clear to everyone. All right. Thank you. So now let's understand one more concept. Okay. So routing protocol, routed protocol. Now these all are just purely related to the common networking, basic networking. Nothing to do with the SD-WAN. But why it's important? Because everything you are going to learn, that's going to relate to the basic fundamental. If your basic fundamental is not strong, you're always going to struggle. So these all concept, even SD-WAN uses their infrastructures to take any routing decisions, to make policy decisions, to make the connectivity. Now there is one more thing is going to be asked. That is the underlay versus overlay concept. Anyone know what is the difference between the underlay versus overlay? Anyone, any idea? What is the underlay versus overlay? Try, guys. Any idea what is underlay versus overlay?
Underlay is just physical connectivity data.
Basic connectivity, right?
Yes.
Okay. And what is the overlay?
Overlay is like where there's channels
tunneling.
between two locations.
Okay.
Overlay is like tunneling
Logical.
protocols, GRE,
Okay.
IPsec, encapsulations, and all.
Very nice. Very nice. So guys, if I talk about the underlay, so underlay is basically, see, if I talk in this small networking, a small network, right? This PC connected with this particular switch. This is connected with this particular switch. This cabling, right? This cabling. So to build underlay, you need the device cabling connections, means connectivity via cable, via wireless also going to work. There is no problem. But also you require the logical addressing. Logical addressing means you have to define the IPv4 or IPv6 addressing to make the communication. So underlays the basic reachability, means to build any network. Let's suppose you have a requirement to build expressway. Okay? Means Agra to Delhi. You need to build the expressway. What is the basic requirement? You require the very good foundations. Means you need to identify the land, and then you just have to bring some good quality of the material like mitti water डालना पड़ेगा आपको, and then you have to build the foundations. After building the foundation, अगर foundation नहीं होगा, you cannot make the very sophisticated road on top of that means area. मानो चला कि गड्ढा है, गड्ढे में कैसे बनाओगे? You cannot do that, right? So first of all, you just have to identify the location A and B, what all area needed, and then you just have to do some kind of the basic foundations, and then after you can just do whatever you want to do that, like nice expressway by doing the concrete road and all. There are a lot of material they are going to use. Similarly, if you want to build the house, your pillars should be very, very strong, because you can build the very multi-floor building if you have the very strong pillar, but you cannot build the multi-story building if you have the very weak pillar. So pillar are where that should be very strong, and then after you can build the multi-story. You can create the cinema. You can create the mall, shopping complex, other entertainment system on that multiple floors. Similar way, if you want to build the sophisticated network, in that sophisticated network, you must have to build a underlay connectivity. These underlay connectivity is known as the basic IPv4, IPv6 reachability. This is your basic IPv4 and IPv6 reachability, that is known as the underlay. This can be formed with the help of the cabling plus logical addressing. Then after, once you have the basic reachability, let's suppose these two routers want to form the overlay. Overlay is basically, they are going to be your GRE tunnel. They're going to form the VXLAN. They're going to form the MGRE. They're going to form the DTLS, TLS. We talk about that. They're going to form the IPsec, GRE over IPsec. There are a lot of things, etc. So if you want to build this all tunnel, very first prerequisite, your point A public IP and point B, let's suppose in two router you want to build the tunnel. Underlay should be okay. If there is no underlay, means you're not able to ping these two public IP address. Let's suppose here is the public IP address 11.11.11.1 and here is 12.12.12.1. These two should be reachable, whether via the IGP, means static routing, via the BGP, or via the default route. Whatever method you want to use, you can use that. So once you have the basic reachability, basic connectivity between these two devices, then after you can build the overlay connections between the routers. And once you build this overlay, this is known as the tunnels. Tunnels can be different type. Can be GRE, VXLAN, MGRE, TLS, DTLS, IPsec, BFD. These tunnels are known as the overlay. So in our SD-WAN also, why I'm just explaining, if I go and explain my SD-WAN topology, very first thing, whenever you're going to start doing the configuration in upcoming classes, you must have to be good with underlay connectivity. Means every device should have the basic reachability. If there is no basic reachability, you cannot do anything. Trust me, my words, right? Means you cannot form any kind of overlay connectivity. The underlay should be okay and it's working, then only you can form the overlay. This is the key concept, underlay versus overlay. Now let's back to the again topology. So few things I discuss RIP versus FRIP. I discuss about the control plane versus data plane. I discuss about the our underlay versus overlay. I hope there is no questions anyone. अगर किसी को क्वेश्चन है मुझे पूछ सकते हो. I can answer that. अब हम बात करते हैं if I have the same topology, okay, and I need to build something very, hold on. Give me 1 second, guys. Okay, leave it. Let me use a different pen. If I have the same topology and I want to build the SD-WAN connectivity, then how my control plane, data plane, and there is a third plane is going to be there, definitely management plane. How it is going to work? So if this router are going to replace with SD-WAN router, then the way of working is going to be changed. As I mentioned in study class also, these routers are going to be brainless router. Means they are going to be brainless router. These all router in SD-WAN, every router are going to be act as a brainless router. Means they don't have any kind of the brain, but still they're going to communicate. You have to extract the brain from the all router and put in the central locations. So the device who is going to be collection of all router brain, that is known as the controller. Okay. So if this PC want to talk to this PC, first they will go to the gateway. Gateway will get the instruction from the brain how to reach to this device. So it will say you have to reach via this, and then it will go there. Then it will packet reach here. Once it reply, again this will go and talk to the brain, and then it will going to send via this one. So this is how your architecture is going to be changed. Means earlier you have the direct communication. Let me erase this and I can draw the nice. Give me 1 second. So earlier we have the direct communication. My individual routers are going to be make the communication. But let's suppose this is my SD-WAN router. Okay. 1. This is my SD-WAN router 2. These routers are going to connect with the switch. This is going to connect with the switch. There is a client connected here. Same situations. 10.10.10.10/24. This is the client B. 192.168. 10.10/24. Again, in between, we have the required the ISP. This is going to connect. This ISP required underlay connectivity. Trust me, guys. This required the underlay. Means you have to form the underlay connectivity, basic IP reachability. Then they are going to form some overlay. They are going to form some tunnel between these two routers. And if they want to talk from this subnet to this subnet, they need to communicate with their brain. And brain is not going to be inside of the router. Brain is somewhere in the different location. That is known as the collection of brain. So if this router brain is going to be there, this router brain is also going to be there. Similarly, if you have multiple router, all routing table are going to be associated by this location. And this device is known as the controller in SD-WAN, and also it's known as the vSmart. This is going to responsible to reflect and give the routing informations from all SD-WAN routers from A location to B, B to C, C to D. Means whatever router you have, you can just do that. So that is my one of the collection of brain where we have to do the all routing. Clear? This is how so your data plane, see, your data plane will remain this path. Means if this PC is going to talk to this PC, again data plane is going to be same. But control plane no in this router. Control plane, no in this router. These all control plane is the central location. Any doubt here? Anyone? Any doubt or we are good till here? Shall I consider okay, everyone? All right, guys. Now we have the further device. The further device we have, that is the management plane. So now we have the control plane and we have the data plane. Data plane is basically these devices are going to act as a data plane. There is a third device which is known as the management plane. This management plane device is going to be responsible to manage all SD-WAN devices. We can say entire SD-WAN fabric. And there a dedicated device going to be used in the remote location. And this is known as the NMS, Network Management System. By using that NMS, this device is known as the manager, or you can just know as the vManage. This device is responsible to do all configurations. If you want to do the monitoring, if you want to do the troubleshooting, if you want to create the policy, software upgradations, means any management related work, you want to do that, you can do as the manager. So there is a third plane, means you want to do the configuration, you want to do the monitoring, you want to do troubleshooting. Again, this device is a third device, means going to sit in the somewhere in the remote location, not on the router, not on the branch. It's a one device or two device or three device in the cluster going to manage a different region of the communications. That is a manager. I'll discuss more about it. There is one more plane is going to use in the SD-WAN. That is known as the orchestration plane. Orchestration plane. This device is a special device. I will talk about more. Again, it's a part of the control plane device, just used to authenticate and onboard the devices. And this device is known as the validator. And this is known as the vBond. So you guys technically have to understand. Let me use that. Means if you're going to learn the SD-WAN, you have to first understand SD-WAN devices. The first device is going to be your manager, which is known as the vManage also, right? Second one is known as the validator. That is known as the vBond also. Third one is going to be controller. This is known as the vSmart. Fourth device is going to known as the vManage. This vManage is going to be your vEdge or cEdge device. Clear? So I will discuss one by one everything in very deeper side. But now understand what is the vEdge and what is the cEdge. So we have to understand now more about the terminology of the SD-WAN because people are very much confused. If I talk about the SD-WAN vendor, okay, in India, in globe, we have multiple vendor available. Multiple vendor. Are they all are using the same concept? The answer is no. Like you can think you are going to purchase the mobile phone. In across the globe, we have the multiple mobile vendors. The basic principle of all mobile manufacturer, you can do the calling, you can do the WhatsApp messaging, you can do the info systems, you can run the any kind of the games, you can do the multitasking work. That's the all phone having the single kind of the end goal. So either you're going to find the Apple, you're going to find the Nokia, Samsung, you're going to find the Vivo, MI, some other Huawei phones. You can do every work from any phones, but what matters their brand value, their security, their reliability, their scalability, and the service center and support system. That's the how. Based on that, your budget, you're going to purchase the best phone from the market, which having the best service, best long lasting kind of the durability, available on that particular phone. Similar way, in market, if you talk about, we have the multiple SD-WAN vendor. Like you are going to know a Viptela SD-WAN, very confusing. You're going to know as a Cisco SD-WAN. You're going to know as a Catalyst SD-WAN. You're going to find as a Meraki SD-WAN. You're going to find as a Versa SD-WAN. Palo Alto SD-WAN. Okay. FortiGate SD-WAN. Zscaler SD-WAN. Cato SD-WAN. Lot of vendor. Nokia Nuage SD-WAN. Nokia Nuage SD-WAN. Silver Peak SD-WAN. Means I can write 20-30 vendors name here. These all vendor are providing the SD-WAN solutions. Every vendor having the SD-WAN solution, and you can opt any of the vendors. Means if you feel I want to go with the Versa, you can go. Exactly, you're going to find the all features. What Cisco offering, what Viptela offering, what Catalyst offering. FortiGate also going to do the same thing. But what matter after getting that solution? What is the support? What is the stability of the product? How much they have the buggy behavior? How much network is going to be stable? This all, and cost is also going to be very important. So if I talk about what we are going to learn, we are going to learn these SD-WAN. Might be you're going to say it's the Viptela SD-WAN, or you're going to say it's a Cisco SD-WAN, or you're going to say it's a Catalyst SD-WAN. These all are same. Okay. So basically, let me tell the story. These all SD-WAN are same. Nothing difference. Means if I'm saying I'm learning Viptela, Cisco, Catalyst, all are same. And this is the only one of the market player who having the very large demand, because only one reason, Cisco having a monopoly in the market. Most of the customer having a Cisco SD-WAN solution, Cisco product. So definitely if you're going to learn Cisco SD-WAN, you're going to get more opportunity from the market. And you're going to get more job opportunity, more kind of the CTC hike from the market. So why Viptela, why Cisco, why Catalyst? Apart from this, these all vendor, Meraki SD-WAN, Versa, these all are different company, but this is all same. Why all are same? Because what happened? Viptela was the company. It's not Cisco company. This was the different company who developed the SD-WAN solutions, and that solution having the 4 component. The first one is going to be vManage. Second one is going to be vBond. Third one was like vSmart. And fourth one was the vEdge. Initially, they are the routers. These are the router and these are the controllers. So they developed the 4 product. So Viptela developed this 4 product in around 2016-15. Around they developed this blueprint and then start scaling this business. And these are the basically Cisco employee who build this company Viptela, and they bring a very good product in the market. Cisco realized that if I want to compete this Viptela, they are already doing the great job in the market. I have to do a lot of research, a lot of R&D, and I have to do a lot of validations. Then my product is going to be live. So why not? I can just go and buy this company. So Cisco actually acquired this Viptela company. So once you do the acquisition of the company, now it's both are going to be same. Okay, so Cisco and Viptela become the same, because suppose you have one of the shop and I purchase your entire shop. So it's my shop. Whatever you did the branding, whatever you have the product, that's all belong to me. I can sell on behalf of you because already you've taken the money. None of your business, right? What I'm going to do that. Same way, Cisco has acquired this company and then they start selling this product. So they start selling the vManage, vBond, vSmart, and vEdge. But the problem arises with the customers. Let's suppose, take an example. I'm your customer. I purchase already very expensive routers and switches, right? Already I paid very good amount, and now you coming to me after 365 day, or might be the 1 year or 6 month. Hey, these all are going to be useless. Now you have to purchase these all devices. So your network is going to be intelligence. So I will definitely feel like, hey, what the hell he's talking? I invested $1 million of money to just bring this all my network in the latest router switches, and this guy again selling me different product. So he feels cheated, means customer is going to feel cheated, and probably they will not agree with the solution. They not have that much budget with the that solutions. So Cisco come with a very good idea. Cisco come with a very good idea. Cisco tell his customer, hey, we are offering the Cisco SD-WAN solutions, Cisco SD-WAN, or might be the Viptela SD-WAN. This is a new term they use, SD-WAN solution. The sales people start doing that. You purchase the only these hardware. vManage, not hardware, that's a controller, vManage, vSmart, and vBond. These product you need to purchase, and if you have the ASR router and ISR router, we can upgrade these to support this controller, and it's become the SD-WAN network. So you just have to take some license and some kind of the activation on this particular. I means you have to upgrade the iOS version and all. Customer thought, yeah, it's a minor expense. Let's suppose you have a car, you purchase the car, and tomorrow your dealer launch Maruti launch one car, and tomorrow the same company launch another car, and saying that, hey, can you just buy this car? Your old car is useless. So you say, why? I lost already 10 lakh rupees or might be 15 lakh rupees to buying your car. Again, you're saying to buy another car, and my all money is going to be lost. So you're definitely not going to buy that car. But if I'm going to say that, hey, you don't need to buy the car, you just buy the additional feature by paying a 2 lakh, and your car is also going to be upgraded as a new car. So you think, yeah, it's a great deal. Why not I can buy the new, why not I can buy the new feature services? Anything could be. So you are happily going to pay that small amount to upgrade your old car. Similarly, customer are very happily say, okay, if I don't have to pay entire hardware cost, I will go and opt this additional services, which is based on the license, based on the iOS upgradation, and these are the controller. Then the network is going to be very smart, very sophisticated. So from there, another device has been invented apart from these four devices. Means vManage was there first, controller, vSmart was there also, and vBond was also there. But for existing customer, they start converting the ASR router, ISR router into cEdge. Means this become the Cisco Edge router. Means they develop the vEdge. But let's suppose customer don't want to purchase the new router. So they offer, you can convert your legacy old iOS based router into iOS XE base. Means if you're going to use that feature, you're going to use that router as a Cisco SD-WAN router, and still you're going to use the same solution. So this is where your Cisco SD-WAN come in picture, and then after you have this product. So you have now vManage, now you have the vBond, now you have the vSmart, and now also you have the vEdge, and then also we have the cEdge. So cEdge nothing, Cisco router converted by changing the OS. Whatever you can just think about, you can just make a note, right? So these all come, but now recently they introduced the new name, the Catalyst SD-WAN. So what is the Catalyst SD-WAN, guys? So Catalyst SD-WAN is nothing. It's just a branding. Earlier it was a Viptela, they changed the Cisco, and now they rename as a Cisco Catalyst SD-WAN. So Cisco Catalyst SD-WAN is nothing. Nothing is changed in your infrastructure. Just they change the branding. Means the just change the name. Means your vManage become the manager. Your v1 become the validator. It's become the controller, and these two become the vManage. So that's only difference. It has been, on the paper, but ground reality is going to be same. So if you are saying I'm learning the Viptela, Cisco, Catalyst, these all are same. They all having a same DNA. Nothing much has been changed, but they just change the branding. And you can see here, this is the new branding. So if you go here, if you are going to find, this is the Cisco SD-WAN. Earlier it was known as Cisco SD-WAN. Hold on. Cisco SD-WAN. Now it's changed the new rebranding. You can see even their official slide, the rebranding. Catalyst SD-WAN. Your vManage earlier become the Cisco Catalyst SD-WAN Manager. Display on the screen, it's going to be Manager. Right? Still in the API documentation, you're going to find the vManage. Means still their API is not updated. So you don't think I don't have the knowledge of the Catalyst SD-WAN or Viptela. They all are same. Don't be confused. Even you can see here, this is where the vAnalytics, vBond, vSmart, SmartPort, everything is same in API and CLI documentation. CLI and API not change. Only they change on the GUI base, graphical user interface. Means we are going to launch on the your vManage, then you are going to find this. And this is going to look like in this. Let me show you display how this is going to. So if I go and log in this, let me show the difference Cisco and Catalyst. So you can find the both nice differences between these two. Hold on, let me log in this Catalyst one first. Sorry, it's Cisco one, this one. So interface tab. What is IP address? 6. Okay, there is a minor glitch is going to happen. I need to switch my network. Hold on. Hold on. We are going to log in the Cisco. This is the look and view of the Cisco SD-WAN. So you can see this is the Cisco SD-WAN. The display name you are seeing that. But if you want to show the Catalyst SD-WAN, let me show the Catalyst SD-WAN also. So let me log in the Catalyst SD-WAN. Viptela is no more. Okay, so you cannot find that. Let me see if I can log in Catalyst SD-WAN. I need the vManage IP address. I do not remember the IP address. So this is my Catalyst SD-WAN. Show interface. What is the IP address? It's going to be 107. Okay. HTTPS 192. It's 107. See, this is your Catalyst SD-WAN. See, Catalyst SD-WAN dashboard. And this dashboard, let me log out here again. This is your Cisco SD-WAN dashboard. No much difference you're going to find. Except this GUIs. If I log in on this also, I can just log in. So side by side, when I go and explain, I will explain the both dashboards. You're not going to be confused. I have the both solutions. And this is a real solution. This SD-WAN is actual deployed solution in our productions. So you can see this is the Catalyst SD-WAN. Here we have this kind of look and feel. And here you're going to log in. This is going to be different look and feel. Okay, this is your different look and feel. So this is just rebranding. Your name has been changed. Your vManage become the manager. Your analytics become the vAnalytics become the analytics. vBond become the validator. vSmart become the controller. Cell portal become the earlier was cell portal. It's known as Cisco Catalyst SD-WAN portal. I will explain what is that. Cloud SD-WAN solution become the cloud deliverance is the same name. No other change has been happened. So this is how the full story is there. Any questions guys till here about all
सर
history we discussed?
एक क्वेश्चन है कि आपका जो वीएज है, वीएज आपका कंट्रोलर से कितने केबल से कनेक्ट होता है?
कंट्रोलर से
मतलब हाउ मेनी केबल वी रिक्वायर टू कनेक्ट वीएज टू मैनेजर एंड वी वी बॉन्ड?
डिपेंड कि कितने ट्रांसपोर्ट हैं, हाउ मेनी ट्रांसपोर्ट यू हैव, बेस्ड ऑन दैट यू हैव टू मेक द केबल कनेक्टिविटी.
Now suppose we have single VS router and we want to connect all this VS to vManage, vBond and all the things.
कनेक्ट हो जाएगा, कनेक्ट हो जाएगा. इसके लिए केबल नहीं है, इसके लिए आपको रिचेबिलिटी चाहिए. एक ही केबल से आपको रिचेबल तो हो जाएगा, कोई दिक्कत नहीं है.
नहीं, जैसे सर स्विच पे मान लीजिए कोई आईएसआर का राउटर है, उसमें आपका एक मैनेजमेंट पोर्ट होता है, कंसोल पोर्ट होता है, ट्रैफिक पोर्ट होता है, तो सभी पोर्ट की रिक्वायरमेंट होती है कनेक्ट करने की या फिर
नहीं
सिंगल?
नहीं नहीं नहीं, आपको ट्रांसपोर्ट वैन लिंक के थ्रू सारे कंट्रोलर कनेक्ट बटन मैं करके दिखाऊंगा आपको विनोद, समझ में आ जाएगा आपको. ठीक है, एक से ही सिर्फ आपको कैसे आप जैसे इंटरनेट पर रीच करते हो ना, तो इनकी आईपी रीचेबल होनी चाहिए बस. यहाँ से आप फिर इन पर टनल बना लोगे. ये टनल बनती है इनकी बाकायदा, डीटीएलएस एंड टीएलएस, कंट्रोल टनल बोलते हैं उसको. तो सिर्फ आपको वैन लिंक से ही ये कनेक्ट हो पाएंगे, और कोई दूसरा तरीका नहीं है इनसे कनेक्ट करने के लिए.
ओके, तो
एक
मीन्स जो आपका वीएस राउटर है उसका कंसोल पोर्ट और मैनेजमेंट पोर्ट का कोई यूज नहीं है यहाँ पे?
है यूज, बट आपको कंट्रोलर से कनेक्ट करने के लिए यूज नहीं है, लोकल मैनेज करने के लिए यूज है. कंसोल से आप क्या करते हो, कंसोल से आप राउटर कंसोल लेते हो लोकली, मैनेजमेंट से उसको सिर्फ आप रिमोट एक्सेस या उसका लॉग इन करने के लिए यूज करते हो. दैट इज द मीनिंग ऑफ द मैनेजमेंट पोर्ट. बट वैन लिंक इज गोइंग टू बी बिल्ड एक्चुअल कंट्रोल कनेक्शंस. ठीक है, समझ में आया?
ओके. हाँ सर, सेकंड क्वेश्चन ये है कि आपने बोला कि अभी जैसे वीएच का जो भी राउटर का कंट्रोलर आपका जो भी आपका कंट्रोल पिन रहता है वो
हम्म.
आपका मैनेजर के पास रहता है, वी मैनेज या फिर जिसके पास भी है ऊपर पर. ठीक है, तो क्या ये अंडर क्लाउड का भी कंट्रोल प्लेन उसके पास रहता है या फिर अंडर क्लाउड और ओवर क्लाउड दोनों का कंट्रोल प्लेन उस ऊपर
दोनों ही
रहता है?
दोनों ही कर सकते हैं. क्लाउड डिप्लॉयमेंट है तो भी कर सकते हैं, नॉन क्लाउड है तो भी कर सकते हैं. बस आपको एक आईपी रिचबिलिटी चाहिए. क्लाउड भी तो एक इंफ्रा ही है ना, डेटा सेंटर ही है ना, वहाँ भी तो हार्डवेयर हार्डवेयर लगे हुए हैं. तो जस्ट हैव टू मेक श्योर कि आपकी रिचबिलिटी होना चाहिए इन्होंने. ठीक
नहीं
है.
सर, मेरा क्वेश्चन है कि जो कंट्रोल इन्फॉर्मेशन रहता है आपका वी मैनेज के पास, वो ओवर क्लाउड अंडर क्लाउड दोनों का कंट्रोल इन्फॉर्मेशन रहता
यस,
है या फिर?
यस, ओवर क्लाउड भी कर सकते हो, अंडर क्लाउड मतलब ओवर क्लाउड मतलब क्लाउड के अंदर भी इसको डिप्लॉय कर सकते हो, और आपने डेटा सेंटर में डिप्लॉय कर सकते हो अपने सर्वर के अंदर भी. दोनों तरीके से लॉजिकल कंट्रोल कनेक्शन बिल्ड करेगा ये, अगर मैं सही समझ पा रहा हूँ तो. ये क्वेश्चन है आपका ना?
नहीं सर, मेरा क्वेश्चन ये है कि मान लीजिए कि अंडर क्लाउड में हमें बेसिक रिक्वायरमेंट चाहिए, ठीक है,
अंडर क्लाउड का मतलब क्या है आपका?
मतलब जो बेसिक कनेक्टिविटी है.
तो बेसिक कनेक्टिविटी तो अंडर क्लाउड जैसे करते हो, जैसे अजूर क्लाउड हो गया, तो आपको वहाँ पे आईएसपी का लिंक तो लेना ही पड़ेगा ना कनेक्ट करने के लिए. आईएसपी तो
ओके.
लिंक बिना कैसे आईएसपी के लिंक से कनेक्ट करोगे? अगर विद इन क्लाउड करोगे तो फिर उनका अपना खुद का वर्चुअल लिंक्स होती हैं जिससे उनका कनेक्टिविटी होती है, तो भी आप कर सकते हो. लेकिन
मैं सर रिफ्रेश कर क्वेश्चन को. एक
हम्म
अंडरले ओवरले, ठीक है,
हम्म
तो
हम्म
अंडरले के लिए आपकी बेसिक कनेक्टिविटी चाहिए. तो मान लीजिए अंडरले में मैंने ओएसपीएफ यूज किया है, राइट, तो उसका कंट्रोल प्लेन भी आपका वी मैनेज के पास रहेगा और ओवरले में आपका है जो कि आपने
नहीं,
टनलिंक बनाई है.
अंडरले का अब आप सही बोल रहे हो, मतलब आपका क्वेश्चन आई थिंक थोड़ा सा अलग डायरेक्शन में पहले था. अंडरले का मतलब अलग होता है. अंडरले का मतलब ये होता है उसे टनल नहीं बनती है, उसे सिर्फ रीचेबिलिटी बिल्ड होती है. पिंग कर सकते हो आप ओएसपीएफ से, बीजीपी से या जीआरपी से या स्टैटिक राउटिंग से. जबकि हम वैन में सिर्फ स्टैटिक या बीजीपी ही यूज करते हैं, ओएसपी जीआरपी नॉट रिकमेंडेड. ठीक है, बट आप कर सकते हो लैब के
ठीक है
अंदर.
सर, तो अंडरले का
तो
जो भी कंट्रोल प्लेन है, जो कंट्रोल इन्फॉर्मेशन है, क्या वो वी मैनेज के पास रहता है, जाएगा?
अंडरले कंट्रोल इन्फॉर्मेशन नहीं बिल्ड करता. अंडरले जब बिल्ड करोगे तब आपका कंट्रोल कनेक्शन बिल्ड होते हैं. वो कंट्रोल कनेक्शन सारे वी मैनेज के पास, वी एच के पास, वी बॉन्ड के पास, वी स्मार्ट के पास रहता है.
ओके सर.
ठीक है, समझ आया अभी?
राइट.
अंडरले सिर्फ आपकी कनेक्टिविटी देती है.
ठीक है सर.
ठीक है, एनी अदर क्वेश्चंस गाइज? चलो तो फिर कल मिलते हैं गाइज. ठीक है, वी कंटिन्यू फ्रॉम हियर क्योंकि आई नीड टू जंप इन अदर मीटिंग. ठीक है, सी यू टुमारो क्लास एंड यहाँ से कंटिन्यू करते हैं. ठीक है,
थैंक
क्वेश्चन
यू
कल
सर.
कल
Okay, sir. Thank you
क्वेश्चन
so
अच्छे से
much.
प्रिपेयर करके आना एंड आस्क मी द बिगनिंग ऑफ द सेशन. ठीक
Okay.
है.